Welcome everyone to my course Formal Methods for System Verification. In today's class, we will learn various decision heuristics that are being used inside the DPLL based SAT solver. Just to recap, we have learned the SAT solver in last 3 classes. So, just to recap what we have learned, basically in the SAT solver you have given CNA formula, set of clauses. What this DPLL based SAT solver does, it basically decides certain variables and their value true or false, and then try to propagate that decision using unit clause propagation, and then try to see what are the other variable can be decided based on these values, right, and that is called BCP. Once no further BCP is possible for a given decision, I change the decision level, go to the next decision level and take another variable and take a decision about that, right. And this way either I get full assignment, all variable get some value, then the formula is satisfiable, or I may end up having a conflict. That means the decision that I have taken here, they are not consistent with the actual satisfactory of the formula, right. So, then what we have done, we basically have a dedicated class on this, that you basically analyze that conflict, identify a new clause that can be learned from this, which basically ensures that you do not make the same decision again, so that you come to the same place and you backtrack to the second most decision level, right, from the current decision level, and then you do the same process again and again until you get the satisfactory or unset, right. So, the part which has not been covered so far is the decide part, right. So, what we have so far talked about, that take a variable, take a value, right. So, if your formula has say 10 propositional constant or variables and you take any of them and assign true or false, but in practice it is not being done, right. That also very important, which variable you are picking, right. In the previous class I have shown a graph where I show that if you take a wrong decision at the start, say x1, and then no matter whatever doing here the BCP and backtracking, finally you have to give up all this and then you have to start from x1 equal to 0 later, right. So, the decision is also a very important part of this DPLL algorithm, and so in today's class we are going to learn about this decide function more, right. So, precisely we are going to learn what variable to choose at the decision level, right. So, I have n number of variables, which one I should pick and what value I should assign to this variable, whether I should assign true or false, right. And if you see that way in very high level, without going into all the heuristics, what is your objective? Your objective is to make this clause satisfy, right. So, now if a variable occur in many clauses, right, or a literal occurs in a many clauses, right, if you take that value, those clauses will be automatically true, right, because every clause is disjunction of the literal. If one of them is true, the entire clause is true. So, obviously I should give priority to the variable, or I would say precisely literal, which occurring most places, right. So, that is something obvious. The second point is that when you are learning new clauses, these clauses are very important, because this is something is additional thing from the existing clauses, and these new clauses are effectively saying that what value can a variable take or what variable cannot take, right. So, these clauses has more impact in the final decision. So, ideally what we should give more priority to this variable that occur in the new learned clause, whatever the conflict clause we are learning through this analyze conflict, we should give more impact to those variables, right. So, in general there is no decisive process here, you have to go by heuristic. Heuristic means you have to logically decide which variable to give higher priority, and they are basically based on these two idea that I just talked about, okay. So, there are many heuristics been used in SAT solvers. So, in today's class I will discuss 4 of them, right, and then you will understand effectively they are effectively following the idea that I talked about just 2 minutes back, right. The first one, the most the older one is called Jaroslaw Wang, based on the inventor name. So, they use this formula, right. So, let us look into this formula, which basically decide which literal to pick, right. So, what they do, you have a CNF formula which has set of clauses. For each literal they compute the JL value, okay. What is this? Summation of 2 to the power minus omega, right. What is this? So, omega is some clause in the formula, right. So, you have a CNF formula which has clause C1, C2, C3 and so on, right. So, and this is AND of the actual formula phi, which is AND of C1 and C2 and C3 and so on. So, what it does? It basically see whether a particular literal occurs in that particular clause or not. Okay. So, if that particular literal occurs in that clause, I just sum 2 to the power minus length of that particular clause, and the length you can assume the number of literal occurs there. Okay. So, it calculates this for each literal, okay, and then it pick the literal that has highest value, GL value, right. So, effectively it pick the L that has highest value. Now, you assume that the literal is basically, if you have a variable x, you have two literal x and not x. If this has more occurrence, it will assume that x equal to false, and if this is has the highest value, JL value, then it will assume x equal to true. Okay. So, this calculation is being done for each literal, and then when I have to pick a variable, I will pick the literal which has highest head count, and based on the literal whether it is a x or not x, I will assign value true or false. So, let us understand that with a simple example, right. Let us say I have a CNA formula has 4 clauses, and these are the clauses, and then you basically have variable x1, x2, x5 and so on, right. So, what I will do effectively for each literal, so for say we have not x4, right. So, literal is not x4, I will see how many places it occurs, x4 occurs here and here, and this clause has 3 literal. So, it is 2 to the power minus 3 and 2 to the power minus 3, one is for C1, the other one is for C2, and there is another occurrence of not x4. So, j of value is this. Similarly, for x10, so this is basically x10 say, okay. For x10, how many occurrences are there? There is only one occurrence, so it is 2 to the power minus 3. Similarly, for x7, how many occurrences are there? Only one occurrence, and the length of the C4 is 2, so it is 2 to the power minus 2. So, this way I will calculate for all literal, right, j of x4, then j of x2, right, then j of not x2, j of x5, j of not x5. So, I will calculate for all literals, right, and then I will pick the one that has the highest value, right. So, if you see here, this has, if you sum this, it is basically 2 to the power minus 1 by 8 plus 1 by 8, right. So, it is basically 1 by 4, and this is basically 1 by 4, right. So, this is 1 by 8. So, when there are two has same value, I can pick any of them, right. So, the point here is that I will calculate these values, and the variable has the highest value, I will pick that one. Okay. Now, what this implies? So, it implies that first thing is that the point is that if a variable occurs many clauses, then you will get many such term, right. So, that will basically say that the literal that occurs more frequently, right, in the clauses. And why I am doing this 2 to the power minus omega? If it is occurring in a smaller clause, that has more importance, right. For example, you see here this occurs in 2 literal, then only its scores become 1 by 4, and this x7 occurs in one clause, still it is become 1 by 4, right. So, because it occurs in a smaller clause as 2 literal, and this x4 not of x4 occurs in 2 clauses of size 3. So, it not only pick the literal that are occurring more frequently, also that is occurring in a smaller clause. And why is the smaller clause? Because smaller clause actually helps you to take a quick decision, because if you have 2 literal in a clause, if you know one of them, I can decide about the other one, right. So, this is why the smaller clause are actually useful in SAT solving time. So, this particular heuristic gives priority to both the high frequency of occurrence and occurrence in a smaller clause. Okay. So, this is how they do, and it basically can be done with static or dynamic. Static means at the start of the SAT solver, I calculate the score for all literal. So, that is static, and I can just use that all the time. Whenever I have to take a decision, I will just see that list and I take the variable which is unassigned, right. On the other hand, the dynamic is where whenever you learn a new clause, you get new clause, right. So, there some literal occurs. So, I can update those literal score because they are now occurring more frequently. So, that is called dynamic. Dynamic is more useful because you are now giving more priority to the clause that you are learning frequently, because their score will grow eventually, but it is something more computation intensive, right. So, for practical cases I think you should follow dynamic, because that is actually makes sure that you are picking the unassigned variable which is occurring more frequently in the conflict clauses. Okay. So, I will move on. The next one is called dynamic largest individual sum. Okay. So, as the name suggests, it is basically dynamic. So, you basically calculate it after learning every clause, and this is basically individual sum, right. That means, for each literal I will calculate the occurrence. Okay. So, what happened here, it basically for each literal, right. So, x not x4, x2, then not x2 should be there, right, then x5 not x5. So, for each literal I will count how many clauses in which this occurs. This is very standard, right. You have to identify the literal who occurs in how many clauses. Okay. So, I will calculate that value at the start, and then every time whenever I at a decision level I have to pick a clause, I will just check the literal that has highest score, right. At decision level, choose the unassigned literal satisfying the largest number of current unsatisfied clause. That means, how many clauses this particular literal occurs, right. This is how I am going to do. Okay. And this is dynamic. What does it mean? You basically, for every new clause you learn, you update this score, right. And it is not only the clause you learn, when you do this, some clause are getting satisfied also. So, you reduce the score for those particular literal that are occurring in those clauses, right. So, what it effectively does, it maintain a graph literal and clauses, it is kind of edges from the literal to clauses. It is basically maintain a sorted list of literal based on the count how many clauses it occurs, and whenever you new clause is learned, you update this value, right, because some literal is occurring in the new clause. Similarly, whenever a clause is satisfied based on the partial assignment due to BCP, we will update that list as well. So, it is dynamically update all occurrence. Some clauses are getting satisfied, their score the corresponding literal score getting down, some new clause being added, so their score is getting up, right. So, this basically every time you keep updating, that is why this is called dynamic. Okay. And this is very simple philosophy, individual sum for every literal, what is the number of occurrence of that literal in the clauses, and based on that you take a decision. Okay. The main problem with this is little bit overhead, because every time you are updating every clause you are getting satisfied or added, it basically add little bit of overhead, right. But this is quite practical approach. Just giving a very small example, you have say 5 clauses and these are the clauses. So, what I do initially start the literal count. So, for example, x1 is occurring in C1, C2, C3 and C4. So, the count is 4. Not of x1 is occurring in nowhere. So, count is 0. Then x2 is occurring in one place, 2 place. So, count is 2. So, this way I count for each literal. Okay. And then if I have to pick, I will pick x1 because it has the highest score at the decision level 1. Okay. So, after so I just assign x1 equal to true, because I am picking the literal x1 not x1. Okay. If I pick not x1, I would have assigned the value x1 equal to false. But whenever you put x1 equal to true, this will become satisfied, right, because x1 is true means this entire clause is satisfied, this is satisfied, this is satisfied, this is satisfied. So, you can see that the impact of picking a variable that is occurring in many clauses, 4 clause become satisfiable. Then you have only C4 is left. Okay. But now in C4 you have x3 and x2. So, what I will do, because this C1, C2, C4 and C5 got satisfied, I will update this score for all literal, because I will not anymore consider C1, C2, C4 and C5, because those is are got satisfied. So, this table will change, right, all the literal that is occurring on those clauses, their value will be reduced. Okay. So, effectively only this clause is left. So, I have only x2 and x3 and their occurrence is 1 1, right. So, I will basically there is no other clause left. So, I will pick one of them, right, in the next step. But this is what is happening in dynamically. After every assignment, I have to update the score. Okay. So, this is how things will go on. This is a smaller example. So, with this you will get satisfiable in my example, but in practical case this might go to a conflict. Then you learn new clause, again update this table, go back to the second highest level, again you pick a variable based on this score, right. This is how this dynamic largest individual sum works. Okay. Moving on to the next one, which is a better version of the VS DLIS, dynamic largest individual sum. This is called variable state independent decaying sum. Okay. So, it is basically state independent, that is very important term here, and decaying sum. So, again I will maintain that same number, that for each literal how many clauses it occurs. So, that table I will maintain at the start, but I will do two things here. As I mentioned, this is very computation heavy, because every clause is getting satisfied, you have to update the table, every new clause getting added, you update the table. So, what it does, but this gives the accurate number, right. So, you have the accurate number, but sometimes computations versus the actual time to get this number versus the accuracy is important, right. So, sometimes if I drop the accuracy by 10%, but my run time become 50% faster, that is better, right, and that is exactly being done in VSID. What I am doing here, it has three key differences with DLIS. So, it is also maintaining this table like DLIS, but the difference is that it does not update the table whenever a clause is satisfiable or not, right. So, it is kind of approximate this value. So, obviously, with this quality of the decision is compromised, but it is to improve the efficiency of the SAT solver. Okay. Then what it does, because it is not reducing, because many of the clause getting satisfied, right. So, but the score is not getting updated, what they do, periodically they divide the score by some factor, right. It may be 2, 3 or something, or you can assume that it is multiplied by 0.5, 0.3 and so on. It is basically to reduce the score across all the veteran. So, what is effectively means, this is being done just to compensate this one, because if you try to update this list every time your computation is high. So, I am not going to update whenever a clause gets satisfied, but after some time, maybe after 10 iteration or something, I will divide the score by 2. So, that means I will lower the score for every literal, but it is not only doing that, the most important step is this. But whenever a new clause add, they update this score, but this is a local one, right, because clause, maybe many clause getting satisfied, but only one clause getting added, only 2, 3 literally occurred there, and I will only update their score. This actually give more importance to the literal that is occurring in the new clause, new conflict clause, and that is important, because we are learning something. This actually helps you to quickly converge to the satisfiability, right. So, what it does is have the initial score, but it does not look into which clause getting satisfied, but only just keep decaying the sum by a constant factor over the time. But whenever a new clause is learned, those variable or literal occurs in those new clauses, their score getting +1. Okay. So, this giving absolute priority to the highest activity this on the conflict clauses. So, why this is state independent? Because whatever this is because of this, right, because we are not updating the score based on the which clause is satisfied or not, right. So, state means how many clause is satisfied, not satisfied. So, I am not taking care of that. And why this is decaying sum? Because of this second step, because we are decaying the value by some factor over the time. Okay. And this is important, because this is useful, because it's give priority to the new conflict clause. Okay. So, this is what is mentioned here, why this is state independent, why it is decaying, right. So, this is exactly I have already talked about, does not depend on the current assignments, it does not depend only on the history of the conflict, right. So, what new conflict is happening, right, variable involved in the conflict give the highest score, and decaying is periodically divide the score by a factor, reduce the influence of the older conflict or older clauses, right. Over the time the clause that was earlier, their value getting reduced, and recent conflict become more important in decision making, right. So, let me take an again example. So, you have say a formula of this, you have 4 clauses here, right, C1, C2, C3 and C4. So, I will again score the literal, right. So, I will get the score like this, x1 is 1, not of x1 is 1. So, if you see here x1 occurs only once, there is nowhere, not of x1 is also once, x3 occur 2 times, right, and so on. So, we will get this score. So, at the start of decision level 1, because x3 has the highest score, I will pick x3, and because I pick x3, so I will assume that x3 equal to true, right. So, once I do this x3, what will happen? There are two, so there is one clause called this, where this is true, so this become false. So, it actually do a BCP and make sure that x1 equal to 4, right. This is what the BCP propagation. So, now let us say after doing this I got a conflict clause learned like this. I am not showing the entire the BCP and all. Let us say I have learned this clause. So, what I will do? I will just increase the score of not of x1 and not of x2 by 1, right. So, what was our initial score? This was the initial score. So, here I will just add 1 and here I will add 1, right. So, this is what I have done here. So, I just add the score of x1 and x2, not of x1 and not of x2 by 1, right. Rest are remain same. So, now which variable to pick, because x3 has already picked earlier. So, this is not unassigned. So, I will not pick this one. Based on that, I will now pick either not of x1 or not of x2, because their score is higher now. So, I will just pick either not of x1 or not of x2 in the next level, right. And say I want to decay the factor by 0.5 or by 1 by 2, right, divide by 2. So, what will happen? Whatever the current score, I will decay by half, right. This is how I will do. Okay. This just to make sure that the older clause importance getting reduced over the time, right. So, this is the summary that I have already discussed, that it maintains a score for literal, score increase on conflict, score decay on over the time, and highest activity unassigned is selected. The particular literal that has the highest score, activity score, but it is unassigned, that value will be selected by the decide function. Okay. The last one I will talk about is Barkpin, which is the is kind of similar to, some similarities there with DLIS and VSID, but this something give absolute priority to the literal occurs in the recent conflict. That is the primary objective. Whatever new clause I learned, I will give absolute priority to literal that occurs there, not the other literal. Okay. So, what they do? They maintain a literal, the score, right. So, it is like the DLIS, that for each literal you can calculate the score. They also maintain a variable list, right, where instead of the literal, if so they count the combine the score of x and not x into 1, right. So, if you have not of x1 score is 2, not of x1 score is 3. So, overall score of x1 is 5 for variable, and this list is static. So, literal score they will never update, that is at the start whatever the literal score they have. Okay. And then they maintain this variable score, and this will be just like VSID, that it will be decaying over time, and whenever a new conflict comes, I will update this, right. So, this both will happen, new conflict clause learnt and the decay will happen for this, the score for the variable, but list, the literal score is static at the start, whatever I have decided, that will maintain that. Okay. So, they also, whenever you learn a conflict clause, they will put this into a stack, and whenever I have to take a decision, what I will do? I will take the top of the stack clause, the last clause that I have learned, right. I will see what are the literal occurs there, and I see which particular literal corresponding variable has the highest score from this table. Okay. So, you can see that I just giving priority to the variable occurring in the last conflict scores, right. This is what I am saying, the absolute priority to the literal that occurs in the recent conflict. I take the last conflict clause, see what variables are occurring there, I see what has the highest value, and I pick that one. Okay. And which value I will pick, x or the true or false, based on this literal score. If x1 has the highest score, has the higher value than not x1, then I will pick true, and if not of x1 has higher value than x1, then I will pick false, right. So, pick the variable based on the score, and then based on this literal score, I will pick the value. Okay. And say your stack is empty, then it is basically normal VSID, right. So, in that time I will just see the variable that has the highest variable score, right. So, this is implementing the SAT solver called Barkpin, so that the name is Barkpin. Okay. So, just to summarize here, this Bach-Min selects a variable that most recently learned, right, in the unsatisfied clause. So, it is a clause based one, that means I am giving the priority to the clause based one, not purely on the activity score, right, just like VSID. Here we are only picking the subset of variable that is occurring in that clause, right, not the all variables. Okay. So, again let me give a small example. Let us say I have these 4 clauses. So, the literal count, it will be happening at the start, right. So, for x1 the score is 1 because x1 is happening only once, not of x1 is also happening only 1. So, the both of them is 1 1 basically, right. So, it is basically 1 1. Similarly, so basically initially everybody occurs once, so everybody's score is 1, and this is static graph, never get updated. Okay. I also calculate the variable score, and the variable score is basically for x1, it is the summation of x1 plus not of x1, right, the literal score of these two, which is 1 1. So, that is why this become 2, right. For x5 it only occurs here, so not of x5 is not there. So, the score of x5 is 1 and not of x5 is 0, right. So, this way I will basically get the variable score, okay, for each variable, and this will get updated whenever I got a new clause, right. So, if new variable say x1 occurs there, I will make a count increase by 1, and also I will decaying this sum over the time. Okay. So, this is just like VSID. Now, you have to, so initially there is no, your stack is empty. So, you have to pick the variable has high score. There are 4 such variable. So, you can pick any of them, right. Let us say I pick x1. So, if I pick x1 from this clause, this is false. So, this become x3 equal to true, which is basically by BCP or unit clause resolution, right. So, the current state is x1 is true, x3 is also true, and then I cannot propagate further. So, I have to go to the decision level 2. In decision level 2, I have to again pick from this set where x1 is already assigned. So, these are the unassigned variable, and 3 of them has a similar score. So, I will pick say x2. So, I assign x2 equal to true because based on the literal score, but both x1 and x2 has the same score. So, I could have put true, false, everything, but let us say I have assigned x2 equal to true. So, with this particular clause will using unit clause propagation, this will become false. So, this x4 equal to true. So, after decision level 2, 4 variables are assigned, all of them are basically true, right. And then in the decision level 3, I will pick the next variable. The only variable left is x5, right, because x1, x2, x3, x4 all are assigned now. So, x5 I pick, and x5 there is no not of x5. So, I assign x5 will say false, and then this is the clause the left out. So, this become false. So, this become a conflict. Okay. So, because this is already assigned true, this is already assigned true. So, this will become false, this will become false, this will become false, right. So, this is a conflict. So, after decision level 3 I get a conflict, and let us say after through this backtracking this conflict clause analysis, I learned this is the new clause, okay, which is not of x1, not of x2 and x5, right, the negation of all these 3. This clause I will put it into stack, okay. And because this x1, x2 and x5 occurs here, their value I just update x1, x2 and x5 score. Initially it was 2 2, it become 3, and x1 x5 score was 1. So, this become 2, right. So, this is how I just increase the clause value, and then in this case I have to backtrack to decision level 2 because decision level 3 the conflict occurs, and so in this case only x5 value will go, and this is the variable is already assigned up to the decision level 2, and from this clause if you do this propagation, which effectively tell you that x5 equal to true, right. So, this is the unit clause propagation, and this is happening because this is asserting clause. But let us say I do not have any variable to pick from, and this is the clause, then what I will do based on the score of x1, x2 and x5, I will pick either x1 or x2 because their score is high, okay, if that situation happen, because if I have to pick from this clause, so I will just take this clause from the stack, I will see their score, and then I will pick either x1 or x2 because they are the highest occurrence, and then which will reduce to clause 2 equal to 5 and so on, right. So, this is how I will basically do, right. Look at the top clause, select the variable that has from this clause, and choose the highest dynamic score, which is basically either x1 or x2, and then polarity based on the literal count. But for both whether I will pick true or false, that based on the literal count, and if you remember in this example for both x1 and x2 the count was 1. So, I can take any of the values, right. So, this is how this bark pin goes on, right. So, these are the 4 heuristic that we have learned today. Just to give the historical perspective. So, this was the zero slope one is the oldest one, early 90s, and then this DLSI one, the which one I talked second, dynamic literal this one, this dynamic largest individual sum, which was proposed next, used next, right. So, which is this is the SAT solver which used them. SATO was using this Jeroslawang, then this was using graphs, and early 2000s we used to have the Barkmin one in a SAT solver Barkmin, but the point from where this our conflict dependent cross learning or this DPLL based methods comes from in 2000 onward, the VSID one, the third one that I talked about, it may have many variants that may use all modern SAT solver like Minisat, Glucose and SAT, right. So, in summary we have learned today 4 different heuristics through which I can decide the variables and their values during the DPLL SAT solving, and the modern SAT solver use the VSID one. Okay. So, thank you for your attention.